Good afternoon, PreCal students. Hope everybody is having a fantastic day. It's Wednesday. I hope you guys dominated the games last night and destroyed Wilmington. Hope those went well for you. And I wish I could have been there to see you guys play. But I hope those games turned out well and we got some victories last night. Today we're going to be looking at lesson 5.3, radical equations. And these equations are just that. They're absolutely radical. Looking forward to showing you guys this concept today. It's actually similar to what we did on Monday, but I think you guys will find this similar and not quite as challenging. I don't know, maybe you didn't think 5.2 was challenging, and if that's the case, then you guys are going to do fantastic on this lesson today. So I'm going to be working a couple of examples. The reason these are called radical equations is because they will have a radical. In fact, the unknown is underneath the radical sign, so we call that the radicand. So these can be very complex, super hard, not too hard, just depends on the problem. I'm going to look at example 1, which is on page, I believe it's 234 for you guys, and you'll see why it's called a radical equation. I have the cubic root of x squared minus 1 equals 15. So you guys can see that the unknown is underneath the radical sign. So that's why, again, it's called a radical equation. So the way we do this is we just isolate the radical. Now, I'm going to teach you the full lesson, so I'm going to go through the whole process. Technically, the first step is to isolate the most complex radical. Now, this only has one. This equation only has one radical, so this one will be fairly simple. So literally what you do is you isolate it. You get it by itself. So I need to take this 1 in basic algebra here, just move it to the other side. So that gives me the cubic root of x squared equals 16. All right? So that's what I get here. And I have this piece here. I got to isolate the radical. Now in this case, on this problem, to get rid of a cubic root, I need to cube both sides. Now we're used to getting rid of the square root by squaring both sides, but here I need to cube both sides. So when you cube a cubic root, they cancel. So I'm left with x squared on that left side. When you cube 16, you get 4,096. So here on your calculators, now I'm ready to take the square root of both sides. Don't forget, it's always plus or minus. So this actually is a perfect square. When you punch that in your calculator, you're going to get plus or minus the square root of 64. And that's your answer. As with the last lesson, you always have to check your work with radical equations. So I literally plug in plus 64 into my original equation, and I plug in minus 64. And when you do, you get both to be equivalent to 15, so both of those plus and minus 64 are your answer. That's it. That's all you had to do on that problem. Pretty straightforward. How about this one? The square root of x minus 5 equals x minus 7. Again, the same step. I got a radical equation with a variable under the radical that I'm looking for. You isolate the radical. This problem, it's already isolated. We have the square root of x minus 5 by itself. So, once you isolate it, you just square both sides on this particular problem. You get rid of the radical sign. You square one side, you square the other. When you square square root, they cancel. They go away. Here, you have to use your FOIL method to figure this out real quick. You're going to get x squared minus 14x plus 49. I'll teach you a little trick today. Whenever you have a square of a binomial in this case, all you have to do is square the first number, or term, in this case it's x, so that would give us x squared. You double the product. The product of x and negative 7 is negative 7x. You double it or multiply it times 2, you're going to get negative 14. And that's where I got my negative 14x. And then the last term is you square the last. So you square negative 7 and you get positive 49. Again, that process is square the first, double the product, and square the last. If you can't remember that or don't want to learn that shortcut, all you have to remember is x minus 7, the quantity squared, is x minus 7 times x minus 7. Foil it out, simplify it, you get the answer that you see on the screen. The x squared minus 14x plus 49. Now, just like last problem, I need to go ahead and get x by itself. So when you do that, I'm going to move the 5 over, or the negative 5 over and the x over, and that leaves me with 0 equals x squared minus 15x, and then plus 54. This particular problem, I can factor this the old method. Factors of 54, we need to add them together, give you a negative 15. That's negative 9 and negative 6. So since the product of these equals 0, we set them both equal to 0. X minus 9 equals 0. X minus 6 equals 0. And sure enough, here you're going to get x equals 9 and x equals 6. Don't forget, you always have to check your work. Check your answers, I should say. So plug both of these values in for x in your original equation, and to see if they do equal what they say they equal. And on this particular problem, they will check out, and your answers are 9 and 6. So there you go, guys. That's a radical equation, how to simplify them. Now they will get a little bit more complex. I'll show you an example of one, but the process doesn't change. This is example 3. The square root of x squared plus 5x plus 3 minus the square root of x squared plus 3x equals 1. Oh boy, this one's a little bit more difficult, but we do it the same way. Remember the steps. Isolate the most complex radical. If you look at this radical and this radical, you notice this one right here is a little bit more complex than the second radical. So this is the one that I want to get by itself. So that's what I'm going to do. First thing I'm going to do is add this square root to both sides. Add it to this side. That's going to leave me the square root of x squared plus 5x plus 3. All of that is going to equal. You could write it either way. I'm going to write it as the square of x squared plus 3x and then put plus 1 outside. Now sometimes, guys, neither one will be more complex. They may be the same. Whenever that happens, it doesn't matter which one you move over. You just got to move one of them over. And here, what we have to do here, guys, is we have to simplify this. So at this point, I'm going to square both sides. So you can see why this one gets a little bit more difficult, but it's not extremely crazy. It's just a little bit hectic here. When you square, the left side's easy. When you square root, they go away. So that's what we have over here. Here, you're going to have to use your FOIL method, or you could do that process I told you guys. Square the first, double the product, and square the last. That one's actually going to be the easier method. If I square this first term here, the square root goes away. If I double my product, this times this is simply 1 times the square root of x squared plus 3x. You double that, you get 2 square root of x squared plus 3x. I just doubled it 2 times that. And then square the last, which would give me 1. That's the easier way to do this particular problem here, in my opinion. Well, thankfully, a lot of things will cancel out. The x squared and the x squared cancels out. That's helpful. It is going to reduce down a little bit more. But here what you have to do is you have to get the radical by itself. So I'm going to take the 3x and move it over, and I'm going to take the 1 and move it over. So 3x, or move it over, it becomes negative 3x. So 5x minus 3x is 2x. Move that 1 over, it becomes a negative 1. That would give me plus 2. All of that equals 2 square roots of x squared plus 3x. Here again, you just keep simplifying it. In this case, I need to go ahead and divide both sides by 2. The 2's here cancel, and I'm going to get x plus 1 on this side equals the square root of x squared plus 3x. And probably from here, you guys can figure out what to do. I need to go ahead and square both sides. And when you do that, you're going to simplify it all out. I'm running out of screen space here. But when you simplify it all out, you're going to end up with x squared plus 2x plus 1 equals x squared plus 3x. So here I'll do it in different colors so we can kind of not get too confused. The x squares cancel. I'm going to move this 2x over here, which will give me 1 equals x. So x apparently is equal to 1. So again, we got to make sure we take this value and plug it in our original equation to check it and make sure it works. And sure enough, when you plug it all in, you will get 1 equals 1. So you know that 1 is your answer for x. Again, a little complex, but not super hard. You're just isolating the more complex radical, squaring both sides, and then simplifying it all the way down. And whatever you get for an answer, got to make sure you check your work, and you should be good to go. I know today's Wednesday, so there's no homework assigned tonight, but we do have several minutes left in class. I'd like you guys to go ahead and look at the exercise A, and I want you guys to do numbers 1 through 10. To see how many you can get done, again, that's numbers 1 through 10. See how many you can complete in that time, and whatever you complete, we'll look at that when I get back tomorrow, and make sure you guys have mastered that and are good to go with that. Hope you guys have a fantastic Wednesday. Looking forward to seeing you tomorrow, and thank you for working hard these last couple of days without me in the classroom. And again, hope you guys have a fantastic evening tonight.